All right. Well, sorry about the delay, everyone. We did have the morning announcement, but if you're not in my class today, we are going to be doing 2 lessons on factor theorem, and this is the morning lesson. Don't forget to like and subscribe, and buy my merch. The Jerome of Hands shirt will be available shortly, and please follow me on Patreon. Every little bit helps. Okay. So, factor theorem says if we're going to do remainder theorem, okay, just a regular remainder theorem, and the result is 0, then x minus a is a factor, right? So if I take f of x here, and what's my a for question A? 3. So if this x minus 3 is a factor, then p of 3 is going to be equal to 0. If it's equal to anything else, it's not a factor. So let's try it out. So p of 3 is equal to 10 times 3 cubed plus 21 3 squared minus 3 minus 6. $270 plus 189 minus 3 minus 6. 450. Now 450 has a 0 in it, but it is not 0. Is x minus 3 a factor of x cubed? No. Let's try x plus 2. Let's try x plus 2. So what am I going to do? P of negative 2, right. No, that's not right. That's 4. Oh, 84. Is x plus 2 a factor? Yes. All right, so let's just put some therefore statements in. Therefore, x minus 3 is not a factor. And x plus 2 is a factor of f of x equals 10x cubed plus 21x squared minus x minus 6. Okay, that's pretty good, eh?
Oh no.
Oh no.
It's gonna be bad now because you say the first part is good and then it's like, no, we forgot C.
We didn't forget.
Have I really conditioned you like that? That when I say, oh, that's pretty good, you're like, oh, that's. So I go for workouts. I'm going tonight. I usually go Monday, Wednesday, Friday. This week I'm going Tuesday, Thursday, Friday. But seriously, whenever he brings out a single little tiny cone like this, I know I'm done for. Like he brings it out, he's like, oh, we're just going to do something with this cone. Oh, please. Whatever you do with the cone, like I have PTSD. He brings out the cone and I get out a little ball and I start rocking on the ground. Maybe that's what he's doing. He's like, okay, do that for 15 more reps. Okay. You know? At any rate.
More like past teachers have done it for us. I'm like, so that's good.
Only math teachers do that?
No, like past teachers, like, so that's good, but wait till the next slide.
Yeah. All right, well, let's try
You're gonna actually.
2x minus 1. What is a in this case? 1 over 2. So can you please work out p of 1/2, and I want you to try that on your own. Because it's a fraction, and fractions are fractions. You can quote me on that. Belle, what did you get?
0.
What's your therefore statement? Yes.
Could you show how you got your fractions, please?
Okay, what's 1/2 cubed is 1/8. 10 over 8 becomes 5 over 4.
Okay.
Okay?
Yeah.
1 over 2 squared is 1 over 4, so this becomes 21 over 4. Minus 1/2, I want it all to be quarters, so it becomes minus 1/2 becomes minus 2 quarters. And minus 6, I want it in quarters, well 6 is 24 quarters. Yes?
Does it have to be in fractions? Like if you did it in decimals, is that okay?
No?
It have to be fractions?
Yeah.
Okay.
A quarter is an exact value. 0.25 is a rounded value.
I got the same answer though.
I want you to use fractions.
Physics use decimals.
These therefore statements are important. I don't just want you finding the remainder, I want you to tell me what that means. Okay? Yes, factor theorem is finding the remainder, but then it's taking it one step further with a therefore statement. Okay. Oops. Was homework help? Belle, were you able to live stream the lessons yesterday?
Yeah.
And were you able to understand remainder theorem?
Yeah.
say this is pretty subtle. Lots of people miss common factoring because you don't think about it. But grouping is another thing you should always try. So when you are puzzling over a question, common factoring is the first thing you should always look for. Because maybe if you take a common factor out, maybe you'll get a linear or a singular polynomial, and then that'll be good. Or see if you can group. So what do I do for grouping? Like, what does grouping mean? Yes?
Just a guess, but would it maybe look like kind of like common factoring out, but like in chunks?
Exactly.
Like two or something?
Right, so we're going to try to common factor these two terms and then these two terms separately. All right, so what's common in this first group? X squared. And I'm left with x minus 3. What's common in the next group? I disagree. -4. Always take the sign of the first term here. So yes, 4, but -4 because the first sign is negative. And then you're left with x minus 3. You know it has common grouping. Why?
Because there's two same things, I guess, brackets are the same.
That's right. And actually what we're doing in this looks like decomposition as well, right? Like it's like that decomposition step. What you're actually doing is you're common factoring here. You're common factoring out an x minus 3, right? So it's like x minus 3 times what gives me x minus 3 times x squared. So the answer is x squared. And x minus 3 times what gives me x minus 3 times minus 4? Minus 4. Okay. Grouping worked. That gave us one factor. But I want to get all the factors. Yes?
Can you do one more step?
Yes?
X squared minus 4
Yes?
to x plus 2x minus 2.
Perfect. What is that? What's that called, Isaac?
Perfect square.
Nope, not a perfect square.
No.
Difference of square.
Well, you got it. Good. Difference in squares. Alrighty. Another thing you could do is, if I had done P of 3, this would have had a remainder of 0. This is not what I asked. I asked you to factor by grouping. But if you were just like trying to find the factors, you could do a P of 3, found out the remainder was 0, and then done synthetic division for that one, and you would have been left with x squared minus 4. But then you have to think, is this still factorable? Okay, which Isaac did. All right, let's try this grouping. Try it on your own. F of A. Oh, I got to do attendance while you're doing that. All right, I get 4a squared, a plus 5. What do I factor out of the next two? -1. Negative a plus 5. So this leaves me with a plus 5, 4a squared minus 1. Who got that? Give you a second to copy it down if you were not quite finished. Factor theorem. It's a good friend. It works for any size polynomial. If I gave you something that was like x to the 20, and you had to find 20 factors, okay? The first thing you would do is you'd try 0, and then 1, and then 2, -1, -2, things like that. You do remainder theorem on them, and when you find a 0, you know that zero remainder, you know that that was a factor. Then what you would do is you would synthetically divide that out. Then once you got that new result, then you would try again. But you wouldn't try the numbers you've already tried because they would have been a factor before. So if you tried 0, 1, and -1 and you found one of those was, well then the next round I might try -2, 2, -3, 3, like I'd work out sort of like that. And then you find that factor, and then you synthetically divide that out. You'd have to do that 19 times to find all of the factors. That would be pretty tough for 20, and calculators will do it for you. All of that, when you get into more advanced calculators, not the calculators you guys own, but you need to get calculators which are called symbolic manipulators.
That sounds expensive.
Mine was, and I could play Tetris on it too. It was pretty awesome. On my calculator. I got kicked out of so many classes for playing Tetris while the teacher was talking. And the thing is it was fine while I was just playing Tetris, but I would get really involved in my Tetris game, and I'd be like this, oh, like that, and in the middle of a lecture or something like that. Bad move. All right. All right. All right, so I want to factor this. So the first thing I would look for is, can I do grouping? Can I do grouping with this? So not easily, I would say not even at all. Yeah, there's no grouping in this. No grouping. All right, but that's the first thing I would check. Now what we want to do is find a factor. So an easy factor to start with is 0. Right? Because substituting 0 in is easy. This would be 0 plus 0 plus 0 minus 2. What's 0 plus 0 plus 0 minus 2? Minus 2. Wow, you did that in your head very quickly. So we know that f of 0 equals minus 2, therefore x minus 0 is not a factor. In fact, there's a quick way of telling that 0 is not a factor, because you have to be able to common factor an x out. or an x squared, or an x cubed, or something like that. Since you can't common factor here, an x out, you know that 0 can't be. Okay, so what would be the next one you would try? 1, I agree. So f of 1 equals 3 plus 8 plus 3 minus 2 is 14 minus 2 is 12. Is x minus 1 a factor? No. Since f of 1 does not equal 0, therefore x minus 1 is not a factor. Alright, so 1 didn't work. What would we try next? Negative 1. Let's try negative 1. F of negative 1 equals negative 3 plus 8 minus 3 minus 2 is equal to 0. Is it okay that I'm going this fast through the substitutions? I mean, in grade 12 university, we don't need to spend a lot of time on making sure you substitute in the value and do all that stuff. I mean, I expect you to sort of do that stuff, or at least know how to do that stuff. But we can use our brains as well. So since f of negative 1 is equal to 0, what can I say?
Therefore, x plus 1 is a factor.
Right, therefore x plus 1 is a factor. Now, it's been a long time since I've taught advanced functions, but I'm going to imagine that a common error is going to be is that people are going to do negative 1 and write down x minus 1 is a factor. So it's easy when you're going from this to recognize to change the sign this way, but just remember you have to change the sign in the other direction, right? Alright, so that's step 1. We've got ourselves a factor, x plus 1. Yay! So what's the next step? Step number 2. Use synthetic division. Who loves synthetic division? Yeah. Well, not everybody put their hand up. That was not a Jerome with hands. Who doesn't even like putting their hand up when I ask questions? There you go. There's an oxymoron. The true people who don't like putting their hands up still didn't put their hands up.
Yeah.
That's right.
That's true.
So we're going to use synthetic division. So let's set this up. We go like this. 2 lines. Minus 1. 3. 8. 3. Minus 2. Bring it down. 3. Minus 3. 5. Minus 5. Minus 2. 2. 0. Here is a check that you did the synthetic division correctly. Here, we found that f of negative 1 had a remainder. It was 0. Therefore, x plus 1 is a factor. I must have 0 remainder here. If you didn't end up with 0 remainder here, either you made a mistake up here or you made a mistake in your synthetic division. Okay? So if this doesn't work, double check something. But that's good. You now have a double check. Like, as in the middle of the question, you can tell whether or not you're on the right track. Because if it works here and works there, you can be pretty certain you got it right. Okay? All right. Now that we have that, we can do step 3. Sorry, which is write all the factors. Well, I guess you can factor the trinomial. So what I'm going to do is I'm going to write out f of x again. So f of x is now equal to x plus 1 times 3x squared plus 5x minus 2. Does everybody see where I got 3x squared plus 5x minus 2? Any questions about where I got 3x squared plus 5x minus 2? Okay, right from the synthetic division. Please factor that on your own. Did you get 3x minus 1, x plus 2? Well done. You just factored a cubic function using factor theorem and then your quadratic factoring skills. That's a good sign. I'm very happy that that happened.